There are over 100 billion galaxies in the universe, each with hundreds of billions of stars, so where are all the aliens? That's the Fermi paradox. Mathematically, the universe should be teeming with life, yet we see nothing. No signals, no ships, no we come in peace. Just silence. Maybe we're the first, maybe advanced civilizations destroy themselves, or maybe they're watching us and just don't want to interfere, the so-called zoo hypothesis. Or maybe there's something out there that wipes out intelligent life before it spreads. The Fermi paradox doesn't just ask if we're alone, it asks why we might be. Still think we're the center of the universe? Think again. Subscribe to the Physics Pen for more cosmic mysteries. Black holes, they devour everything, even light can't escape. But what happens to information that falls in? In the 1970s, Stephen Hawking proposed that black holes evaporate over time, releasing Hawking radiation. Cool, right? Except, that radiation contains no information about what fell in. So when the black hole disappears, that info is gone forever. But wait, quantum physics says information can't be destroyed. Ever. That breaks the laws of physics. This clash is called the black hole information paradox, and it rocked the world of science. Decades later, Hawking admitted he may have been wrong. Maybe the information escapes, somehow. Or maybe space and time themselves change at the event horizon. Solving this paradox could unify general relativity and quantum mechanics, the holy grail of physics. Black holes don't just stretch space, they stretch our understanding of reality. Follow the Physics Pen for more cosmic paradoxes. Did you know astronauts actually age slower than us on Earth? This is not science fiction, it is real physics. It is called time dilation, a strange side effect of Einstein's theory of relativity. According to relativity, the faster you move, especially close to the speed of light, the slower time ticks for you compared to someone at rest. So when astronauts orbit Earth at 28,000 kilometers per hour, time actually runs a tiny bit slower for them. In fact, astronaut Sergei Krikalev spent 803 days in space, and aged 20 milliseconds less than us. It sounds small, but if you traveled near light speed, you could stay 30 while centuries pass on Earth. So yes, space really is a time machine, and astronauts? They are our first time travelers. Mind officially bent? Subscribe to the Physics Pen for more brain-melting physics facts. Imagine a place where atoms completely stop moving. That's absolute zero, minus 273.15 degrees Celsius, the coldest temperature possible. But here's the catch. You can never actually reach it. Why? Because of quantum mechanics. Atoms always have a tiny bit of motion called zero-point energy, even at their coldest. But scientists have come dangerously close. Using lasers and magnetic traps, they've cooled atoms to just a few billionths of a degree above absolute zero. At that point, atoms behave like waves, merge into one weird state called a Bose-Einstein condensate, and quantum rules take over. It's like matter entering an alien phase. But go all the way to absolute zero, you'd need infinite steps and infinite time. Nature just won't let you. Still, the closer we get, the closer we are to unlocking quantum secrets, and maybe the future of computing. Cool, right? Subscribe to the Physics Pen for more physics that chills and thrills. Ever wondered what it would be like if Earth had rings like Saturn? Imagine the breathtaking sight of looking up and seeing glowing rings stretching across the sky, a celestial spectacle that would redefine our view of the heavens. These rings would be a constant, mesmerizing presence, visible both day and night, transforming our skylines into something out of a science fiction dream. But how would they change our world? From stunning skylines to potentially wild weather patterns, the impact would be profound. From the beauty of the rings to the chaos they might bring, let's dive into this cosmic what if on the Physics Pen. Welcome to the Physics Pen. If you love mind-blowing science and exploring the wonders of the universe, hit that subscribe button. To understand what Earth with rings would be like, let's first look at Saturn. Its rings are made of ice, rock, and dust, creating a stunning visual display. These rings span an incredible 280,000 kilometers but are surprisingly just 10 meters thick. Such a thin yet expansive structure is truly fascinating. If Earth had rings, their appearance would depend on their origin. Were they formed from a shattered moon or asteroidal debris? The source of the rings would determine their composition and look, adding another layer of intrigue to this scenario. Imagine our skyline with these rings. In some places you'd see a glowing arch day and night, a constant reminder of the cosmic forces at play. At the equator, the rings would be directly overhead, creating a spectacular view. At higher latitudes, they'd appear closer to the horizon, offering a different but equally stunning perspective. Nights would be lit with dazzling bands of light, turning our nocturnal skies into a natural light show. However, these rings would pose significant challenges for satellites and space travel. The debris could make launches and orbits much more complicated. Spacecraft would face constant bombardment from ring particles, making space missions risky and difficult. Ancient myths and astronomy would be totally different. The rings would have inspired countless stories and legends, altering our cultural history. Rings could block sunlight, cooling Earth slightly and potentially affecting our climate. They might even change wind patterns and seasons, leading to new weather phenomena. Could Earth get rings again? It's possible, especially if a large asteroid were to collide with our planet, creating new rings from the debris. So, would rings make Earth more beautiful or dangerous? They'd create stunning views, but also bring significant challenges. Would you love to live on an Earth with rings? Let us know in the comments, subscribe and hit the bell for more amazing content on the Physics Pen. See you next time.